Hello students, this is Umair Ahmed. Today we're going to learn about the chapter real numbers, okay, which is the first chapter of your class 10 standard. Before getting into this chapter, we'll learn what is mean by real numbers, okay. Till now we have learned what is mean by whole numbers, natural numbers, integers, all of this. Quickly we'll revise all of those numbers, what exactly it is. Then we'll come to the topic of real numbers, okay. Can you help me out? What is mean by whole numbers? Whole numbers start with the digits. What is start with the digit 0, 1, 2, 3. Correct. Natural numbers start with the digits 1, 2, 3, infinity. Correct. Let me represent in the form of a table so that you can understand clearly. Whole numbers are represented with the digit with the alphabet W. Okay. Then comes natural numbers. Natural numbers is represented by the alphabet N. Correct. Then what is integers? Integers are the numbers which constitute both positive and negative number. Constitute both positive ... -2, -1, 0, 1, 2, 3 up to infinity. Integers are those numbers which have both positive and negative numbers. Let me represent it over here. Integers are represented by the alphabet I. Okay. थोड़ा जलेबी बन गई, थोड़ा इसको सीधा कर लेंगे. चलो, होल नंबर्स कौन से हैं? होल नंबर स्टार्ट होंगे 0, 1, 2, 3 से. नेचुरल नंबर कहाँ से स्टार्ट होंगे? 1, 2, 3, 4, 5, 6, 7 अप टू इंफिनिटी. करेक्ट. इंटीजर्स किसको बोलते हैं? बोथ पॉजिटिव एंड नेगेटिव नंबर कॉन्स्टिट्यूट इंटीजर्स. ओके. Until we have studied, till now we have studied this in grade 7, 6 and everything. Now integers, whole number, natural number, integers. Then we'll come to the topic rational numbers. Rational numbers. Even you have heard this in class 9 standard. Definition of rational number. Rational numbers is represented in the form of P by Q, where Q is not equals to 0. These sentences we have read. Let us understand what it is. This सुनते आ रहे हैं. It is represented by in the form of P by Q. क्या है? मतलब we don't know exactly what is it is. Let us understand this with example. Okay. Assume P is 1 and Q is equals to 2. 1 by 2. When this numerator and denominator have some values, then this particular number is said to be rational number. Let me repeat the sentence. What is exactly the rational number? Rational number is defined as the numbers which is represented in the form of P by Q. The numbers which is represented in the form of P by Q. Those numbers are called rational number. And there is one condition where Q is not equals to 0. Q is not equal to 0. Q जो है Q की वैल्यू जो है 0 नहीं हो सकती. Q की वैल्यू 0 नहीं हो सकती. ठीक है. अगर 0 हो गई, मान लो अगर 1/0 लिखा तो क्या है? नॉट डिफाइंड है, नंबर ही नहीं है उसका, नॉट डिफाइंड है. बट P can be 0. Hope this is clear. Okay. Now the question comes whether the decimal numbers comes in rational numbers. Decimal number can come in rational number. Correct. Take an example which I have written 0.75. Whether this number is a rational number or what? Yes, this is a rational number. How can I write this number? 3 by 4. If you divide 3 by 4, you'll be getting 0.75. Hence I can tell the decimals also includes in rational number. Decimal number also includes in rational number. Clear? Hope this is clear. Now what are the numbers exactly? We can tell decimal number. We understood rational number sentence. We understood decimal numbers are included in rational number. Okay. Now two things I'll give you the clarity. Okay. Here I'll include rational numbers. Okay. 1 by 2. If you take an example, 1 by 2, I'll be getting 0.5. 1 by 2, 0.5. It is stopping. After decimal point, this number is getting stopped. So this is called terminating. The word we have used in grade 9. Terminating. Okay, the number is getting terminated. So this is also called rational number. Okay. Similarly, I gave an example previously 3 by 4. What I am getting? 0.75. This is also terminating. This example is also called rational number. Okay. Now we'll take an example 1 by 3. 1 by 3. Where I'll be getting 0.33. Keep on going. Which is non-terminating. What we'll tell? What is the word we use? Non. अरे ये नंबर जो है खड़ नहीं रहा है, जाते जा रहा है, 3 पॉइंट जाते जाएगा, इन्फिनिटी जाते हैं, 0.333 डॉट 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 और इन्फिनिटी जाते हैं. Non terminating, but this number is getting repeated. Number is getting repeated. So this number is also includes in rational numbers. The number which is terminated, which is in the form of decimal and getting terminated, those numbers are called rational numbers itself. The number which is non-terminating, but it's repeating. I have given the example over here, but it's repeating. Okay, here 2 by 11, 2 by 11, 0.181818. It's repeating 181818. Keep on repeating. Those numbers are also called as rational numbers. Those numbers are also called as rational numbers. Non-terminating but repeating. Non-terminating but repeating. Hope it is clear. Okay. Now question comes into picture. Non-terminating we understood. But if the number is non-terminating and non-repeating, those numbers what do we call? Those numbers are called irrational numbers. Those numbers are called, which is very separate from all of these. Okay, irrational numbers. It's very separate. It's very separate from all of this. अलग ही है भाई बंदा, ये इरेशनल नंबर्स क्या है? नॉन रिपीटिंग, नॉन टर्मिनेटिंग. एग्जांपल ले लो, √2. ओके, इसकी वैल्यू लगभग 1.4 कुछ आएगा. इसके बाद 1 2 3 जाते रहेगा. रकम के नंबर आते जाएंगे. Different kind of numbers you will be getting after decimal point. So that number is called as irrational number. Take an example, pi. Pi की वैल्यू हमने 22/7 पर हमें, अगर इसको सॉल्व करेंगे तो क्या रहा हमारे 3.14155. ये नंबर को क्या बोला जाएगा? Irrational number. In simple words, irrational numbers. The numbers which is not in the form of p by q. The numbers which is not in the form of p by q. Those numbers are called irrational numbers. Hope it is clear. Hope this is clear. All of these numbers. Okay. Irrational plus rational. All of these numbers, irrational plus rational, together constitute real numbers. Which is a chapter name. अरे आया समझ में. Hope it is clear. Rational numbers are those numbers. The number which is represented in the form of p by q are called rational numbers. Correct? If the number is terminating, those numbers are also called rational number. If the number is non-terminating but repeating, if the number is non-terminating repeating, those numbers are also called rational numbers. But if the numbers are non-terminating, non-repeating, those numbers are called irrational numbers. All of these numbers together, rational number plus irrational number together, called real numbers. Okay, hope you understood. We'll come to the topic divisibility rules right now. So we will be solving the divisibility rules from numbers 2 to 11. First we got the number 2. Okay, assume the example 246. If this is a number, if you want to check whether this number is divisible by 2 or what, so last digit should be even. The last digit, which is unit place should be even. If this is even, that particular number is said to be divisible by 2. Let us check once. 246 divided by 2. 2 1s are 2 1s are 2. 2 2s are 4. 2 3s are 6. So 123 is the answer. Yes, it is divisible. This number is divisible. Check this number. The even place is 108. The even place is even. The unit place is even. The unit place is even. Hence, this number is divisible by 2. So both of these numbers is divisible by 2. I can tell that This number, if the unit place is even, the whole number is divisible by 2. Clear? With this example, we can see here the 7 is in not a even number, hence this number is not divisible by. Hope this is clear. Hope this is clear. Next we'll come to 3. Sum of digits divisible by 3. Sum of digits. Take an example. Okay. For 3, example if you take 123, sum of the digits. 1 plus 2 plus 3. How much? 1 plus 2, 3. 3 plus 3, 6. Correct? If this number is divisible by 3, the whole number is divisible by 3. The whole number is divisible by 3. 123 divided by 3, if we check, 3 1s are 3, 3 4s are 12, 3 1s are 3. Hence, this number is divisible. Hope it is clear. Take another example, check yourself whether this number is divisible. And let me know in the comment section. 405. 1 2 3 is divisible? Yes. Similarly, 124, if we check, add up this all, 1 plus 2, 3, 3 plus 4, 7, correct? But 7 is not divisible by 3. So hence it is not divisible. This number is divisible. Hope it is clear. Next, go with the last 2 digits. Last 2 digits should be divisible by 4. For divisibility rule of 4, the last 2 digits must be divisible by 4. Take an example. 316. These 2 digits, last 2 digits must be divisible by 4. This 16 is divisible by 4. Yes. How? 16 divisible. How much? For how much? 4 4s are 16. Correct? 4 4s are 16. Hence, this whole number is divisible by 4. The whole number is divisible by 4. Let us check. 4 1s are 4. 4 how much? The nearest number for 31. 4 how much? 4 8s are 4 1s are 4. 4 4s are 16. 4 8s are 34. Cut. 4 2s are 4 3 are 12. 4 4s are 16. 5s are 20. 4 6 are 24. 7 are 28. We'll take an example. We'll take this number 316. 316. Okay, divisible by 4. 4 1s are 4 7s are 28. 4 7s are 28. How much is remaining? 3. 4 8s are 32. 4 9s are 36. Hence, 79 is divisible. Hence, I can tell that 316 is divisible by 4. 316 is divisible by 4. Similarly, you can check for 120. You will be getting. So, hence, this number is divisible by 4. 782. Cross check once. These 2 places. 82. 82 is not divisible by 4. Just check once. 82 divided by 4. 4 1s are 4. 4 2s are 8. But 2 is not divisible by 4. Hence, this number is not divisible by. Hence, this number is not divisible by. Let us come to digit 5. See, for number 5, it's very easy. The unit place should have 0 and 5. The unit place should have, what did I say? The unit place should have 0 and 5. That's it. यूनिट प्लेस के पास 0 और 5 रहा तो ये पूरा नंबर 450 और 735 ये पूरा नंबर डिविजिबल होगा 5 के टेबल में. सिंपल टू रिमेंबर. चेक वंस. विल टेक द एग्जांपल 735. ओके, डिवाइडेड बाय 5. 5 1s are 5. 5 1s are 5. 2 remaining. 5 4s are 20. 3 remaining. 5 7s are 35. So 147. It is divisible. Hope it is clear until here. Until here is clear. Okay. Check with this. See, the unit place doesn't have 0 or 5, so it is not divisible. And these two are divisible. Hope it is clear. We'll come to the divisibility. Divisible by the number 6. If the number is divisible by 2 and 3, if the number divisible by both 2 and 3, the whole number is said to be divisible by 6. Let us check. 324, correct? So what is a rule? It should be divisible by what? 2 and 3. So to divide this number with 2, the unit place should be even, correct? The unit place should be even. We can tell that this is satisfied. But for the divisibility of 3, we have to add up all of this number 324. 3 plus 2 plus 4. How much? 3 plus 2, 5. 5 plus 4, 9. This number, if it is divisible by 3, then the whole number is said to be divisible by 3. Now, both are getting satisfied. Hence, this given number is divisible by 6. Hence, this given number is divisible by 6. Let me repeat it again. If the given number is divisible by both 2 and 3, the whole number is said to be divisible by 6. 4 is unit place. 4 is in unit place. Hence, 4 is even number which is in unit place. When it is an even number, then the whole number is divisible by 2. What is the rule divisibility? What is how to check the divisibility of 3? The sum of all the digits should be divisible by 3, then the whole number is divisible by 3. If both of this is satisfied, then I can tell the given number will be divisible by 6. Let us check now. 324 divided by 6. 6 ones are 6. 6 6 are 36. Now 6 5 are 30. How much is remaining? 2. 6 how much are? 6 4 are 24. Hence that is. Check with this number and let me know. This number is divisible. If you actually this number 210 is divisible by both 2 and 3. Both 2 and 3. Since we know 210 it is divisible by 2, even 0 is an even number. 210 is divisible by 2, correct? It is satisfying. Then if you add up all of these numbers, 2 plus 1 is 3, correct? 2 plus 1 plus 0 is 3. 2 plus 1 3. Hence 3 is divisible by 3. Yes, if both is satisfying, this number is said to be divisible by 3. Okay, we'll change this number. Change 208. Put the number 208 and check. Now, if you see the even number 208 unit place, the unit place is even number. The unit place is even number, so it is divisible by 2. It is divisible by 2. Then add up. If you add up 2 plus 0 plus 8, 8 plus 2 10, but 10 is not divisible by 3. In the condition of satisfying 2 and 3, 2 is getting satisfied, but 3 is not getting satisfied. Hence, the given number 208 is not divisible by 6. See, given number is not divisible by 6. Clear. Divisibility for 7. This is little tricky. Pay attention. This is little tricky. Double the last digit, subtract from rest. It's very simple. See, 203. Okay. The last digit, which is 3. Okay. The last digit, which is 3. Double it. 3 into 2 is how much? 2 times 6. Correct. And subtract with the remaining number. This remaining number 20. 20 minus 6. If you subtract 20 minus 6 is how much? 14. 14. If this number is divisible by 7, then the whole number is divisible by 7. The whole number is divisible by 7. Hope it is clear. You check with this 301 and let me know in the comment section. These numbers are divisible, but this number is not divisible. Let us check with this 234. The last number, if we double it, 4 double is 8. Okay. Subtract with the remaining. Number. 23 minus 8 is equals to 15. Correct? But 15 is not divisible by, 7. Hence it is wrong. We can tell that this number 234 is not divisible by 7. Hope this is clear. 2, 3, 4, 5, 6, 7. This is clear. Let us go with the 8. See, 8 is not that important to learn to solve the problem for LCM and HCF. Okay, but keep in mind how to remember it. 4128. Assume what I have written. Last 3 digits divisible by 8. Last 3 digits should be divisible by 8. 4128. These last 3 digits, which is 128, if it is divisible by 8, the whole number is divisible by 8. Let us check. 128 divided by 8. 8 ones are 8. How much is remaining? 4. 8 8s are 64. No. 8 5s are 40. 8 6s are 48. So 16 is divisible by 8. Then I can tell the whole number is divisible by 8. Hope it is clear. Check with this 560 and let me know in the comment section. This is not divisible. Let us check 3562. These last 3 digits should be divisible by 8, correct? So 35562 divided by 8. 8 ones are 8 5s are 40, 8 6 are 40, 8 7s are 50, 7 8s are 56, 8 7s are 56, 7 8s are 52, 7 8s are 8 7s are 52. How much is remaining? How much is remaining? 4. 8 6 are 48. 8 5s are 40. 3 5 6 2. But yes, 42 is not divisible. 42 is not divisible. Hence, I can tell that the whole number is not divisible by 8. Clear? Clear? See, next we'll come to 9, 10, then we'll go to 11. Sum of the digits to be divided by 9. Sum of the digits is divisible by 9. It is similar to, this is similar to 3 is similar to 9. 3 is similar to 9. How? See the given number 729. If you add up all of these numbers, 7 plus 2 plus 9. Okay, 7 plus 2 how much? 8, 9. 9 plus 9, 18. Correct? If this number is divisible by 9, and 1 is 9, 2 is 18, the whole number, the given number is divisible by 9. The whole number is divisible by 9. Let us check 729 divided by 9. 9 9 is 81, no, 8 9 is 72, 8 9 is 72, 9 8 is 72, then 9 1 is 9, 81 is divisible. Hope it is clear. Okay, check with this example and let me know. 563, if you check with 563, it will not be, it doesn't work. Let us not waste much time on this. We'll go with 10. See, 10 is very easy. Divisibility check for 10. If the unit place has 0, the whole number is divisible by 10. Simple funda. If the unit place have the number digit 0, the whole number is divisible by 10. I have given examples. Just check with this. Obviously, it will be divisible. These numbers are not divisible. These numbers are not divisible. Difference of odd and even places should be divisible by 11. Okay, or 0. Let us check. Let us check with this. Difference 2 7 2 8. So this is, I'll consider this is odd and this is odd. This is even. This is even. So if I add up all of these odd numbers, if I add up 2 plus 2 is equals to 4, correct? Even places, if we add up 8, 7 plus 8 is 15. 7 plus 8 is 15. If I do the difference, if I do the difference of these number, 15 minus 4, I have to get what? What I'll be getting? 15 minus 4, 11. If this is the condition, this is a condition. If you get 11 or 0, then this whole number is divisible by 11. I've given the example for this. You can check out with this 121. Just quickly we will check out to 121. See the odd places, 1 plus 1, 2, correct? Then we remain even places only 1, 2 plus, if you do the difference, you have to be very careful. You have to do the difference. 2 minus 2 is 0. Okay, 2 minus 2 is 0. Hence it is satisfying. If the answer after difference, if you get 0 or 11, the whole number is divisible by 11. Okay, the whole number, this both are getting satisfied, but if you check with this, it will not be divisible. Check here. 1 plus 3, 4 minus 2 is 2. We are not getting either 0 or 11. Hope this everything is clear. Let us quickly revise this. Okay, let us quickly revise this. Divisibility check for 2. Okay, divisibility check for 2. If the given number, okay, we'll go with the understanding with Hindi. Okay, अगर दिया हुआ नंबर पे यूनिट प्लेस पे अगर इवन नंबर है, यूनिट close your eyes and tell. In a given number, in a unit place, if it has 2, in a unit place, if any number is even, the whole number is said to be divisible by 2. Whole number is divisible by 2. Go to divisibility check for 3. Sum of all the digits, पूरे नंबर को ऐड करेंगे जो भी नंबर दिया है. अगर वो नंबर अगर 3 के टेबल में डिविजिबल होगा तो वो पूरा नंबर जो है डिविजिबल बाय 3 होगा. 4, द लास्ट 2 डिजिट्स, लास्ट के 2 डिजिट अगर डिविजिबल होंगे 4 से तो पूरा नंबर डिविजिबल होगा 4 से. 5 इज वेरी इजी. द यूनिट प्लेस शुड हैव 0 और 5. द यूनिट प्लेस शुड हैव 0 और 5. Then it's said to be, the whole number is said to be divisible by 5. छः में अगर जाए 6 में जाए, 6 का क्या कंडीशन है, डिविजिबल बाय 2. अगर 2 और 3 दोनों सेटिस्फाई हो रहे हैं तो वी कैन टेल दैट इट इज डिविजिबल बाय बोथ. द गिवन नंबर इज डिविजिबल बाय 6. If the given number is satisfying the divisibility check for both 2 and 3, then the whole number is divisible by 6. Hope it is clear. 7 is very easy. It's little tricky, but it's very easy. Double the last digit and subtract with the remaining digit. Double the last digit, subtract with the remaining digit. If that number is divisible by 7, the whole number is said to be divisible by 7. 8, it is also easy. Sum the all last 3 digits. Sum the all last 3 digits. Okay. If it is divisible by 8, the whole number is said to be divisible by 8. 9. 9 is also easy. Okay, how? Sum of all the digits is similar to 3. It is similar to 3. Sum the all the digits. If that number is divisible by 9, the whole number is said to be divisible by 9. 10 is very easy. If the unit place have 0, then the whole number is said to be divisible by 10. 11, you have to take the addition of odd places. Okay, and addition of odd places and even places, and subtract the odd and even. If you get 0 or 11, 0 or 11, then the whole number is said to be divisible by 11. Otherwise, it is not divisible. Hope this is clear. Hope this is clear. Once close your eyes, relax, aram se use it. Okay, tell without saying all of this. It will be very helpful for you to solve the problems for LCM and HCF. Okay, clear. This chapter is divided into real numbers. Is divided into two parts. Real numbers. One is HCF and LCM. Okay, and second is irrationality. Okay, in HCF and LCM, you got the problem solving. The problems is related to factorization method. You need to solve the problems for HCF and LCM. Then you got word problems. And also you got the relation between LCM and HCF. HCF into LCM is equals to product of two numbers, which you can assume as A into B. Okay, this thing, word problems and product of two numbers, will come this topic later. Okay, now we'll try to understand what is meant by HCF and what is meant by LCM. You know what is meant by LCM? The expansion of LCM, students. Hope you have heard in your schools. Okay, least common multiple. What is meant by this? Let us take an example. 6. Okay, let us take an example. What is the multiple of this? 6, 12, 18, 24, then 30, 36. Keep on going. Correct. What is the multiple of 8? We'll take an example 8. What is the multiple of 8? 8, 16, 24, 32. 8, 16, 24, 32. Then 40, 48. Correct. Multiples. Multiple of 6, 12, 24, 6, 12, 18, 24, 36, 30, 36. Correct. 8, 16, 24, 32, 40. In this, can you see something common? 8, no. 16, no. 24 is common in this. So we can tell this is a least multiple. In this 6 and 8, the least multiple, the least common in this, least common multiple, least common. And this, the least is 24. Hence, I can tell the LCM is 24. Hope it is clear. Let us come to HCF. What is HCF? Highest common factor, not multiple, factor. Highest common factor. Even here we got the word common, something we're doing common. Okay, highest common factor. We'll take the same example, 6 and 8. Okay, 6 is divisible in which tables? 1. Okay, it's divisible in 1. 2, yes, 2 3s are 6. 3, 3 2s are 6, yes. 4 in 6 is not divisible by 4 table, correct? Then 5, no. 6, yes, it is divisible by 6. Factors. These all are the factors. 1, 2, 3, 6, whatever I have written, these are called factors. Factors of 6. Factors of 6. Next. 8 is divisible in 1. Yes, 1 8 is 8. 2, yes. 3, no. 4, yes. 5, no. 6, no. 7, no. 8, yes. In this both, what is common? Can you see? Can you see what is common in this? 2 is common. 2 is common. Hence, I can tell highest common factor in 6 and 8 is 6 and 8 is. Hope it is clear. This is general way of understanding what is meant by LCM, what is meant by HCF. LCM is least common multiple. HCF is highest common factor. Okay. In the multiples of 6 and 8, I have got the least multiple as 24. In the factors of 6 and 8, I got the factor as the highest common factor in this both is 2, which I have written HCF. Okay. Now the same thing we'll try to understand the same thing with the help of factorization method. Factorization method. Before getting into this, I wanted you to know what is meant by prime numbers and composite numbers. Composite numbers. Have you come across with this? What is prime? What is composite numbers? It is simple. Prime numbers are those numbers which has factors 1 and itself. Which has only factors 1 and itself. Or you can tell prime numbers are those numbers which is divisible by 1 and itself. The numbers simply the numbers which is divisible by 1 and itself. 1 and itself. Example. What can you give the example? Example 2. Just think 2 will go in which tables? 1, correct? And 2. Other than these two tables, will 2 is divisible in any other table? No, correct? Hence, this is called a prime number. Hence, this number is called prime number. So, as such, 2, 3, 5, 7, 9. 9 is a prime number? No, because it will go in 3 table, 1 table, 3 table, and 9 table. So, it has more than 2 factors. So 1, 2, 3, 5, 7, 11, 13, okay, 17, 23. These numbers are called prime numbers. Prime numbers. Now, what is composite number? What is composite number? Just now I discussed you about 9, correct? 2, 3, 5, 7. I went up till 9, correct? So this number 9 is divisible in 1 table, 3 table, correct? 3 3s are 9. Then it is divisible in divisible. Come on, tell me which tables? 3, 4, no. 5, no. 6, no. 7, no. 8, no. 9. Correct? It is getting divisible by more than 2. The numbers, I'll write it here. The numbers divisible by more than 2 factors. More than 2. The numbers which is divisible by more than, for your understanding, more than 2 tables also you can write. 2 tables is called composite number. For just your understanding, I have written this. Okay. The number which is divisible by more than 2 tables, the number which is divisible by more than 2 factors are called composite number. Example 9. Hope this is clear. What is composite number? Now, with the help of this, we'll try to understand the prime factorization method. We'll take the same example 6 and 8. The question will be find the LCM and HCF of 6 and 8 with the help of prime factorization method. Prime factorization method. How to do? 6, it's an even number. It will be divisible by even table. 2 3s are 6. 3 1s are 3. You can keep it as it is. 8. 2 4s are 8. 2 2s are 4. Or you can write it further, or you can stop it here itself. 2 1s are 2. Now, what are the factors of 6? 2 into 3. What are the factors of 8? 2 into 2 into 2. Correct? If you want, you can write 1 also. No worries. How to find the LCM? How to find the LCM? Concentrate. Further, can I solve this? 2 power 3. Can I write it? 2 into 2 into 2. I can write it 2 power 3. This has 1 power. This has 1 power. Everything. Okay. In these both 6 and 8 factors, what kind of numbers we can see here? What kind of numbers we can see here? 2 is visible. 3 is visible. Correct? 2 is visible. 3 is visible. Here 2 is visible. Already wrote. 3 is visible. Correct? It's here. There is no 3. I have written. 1 is there. If you want, we can write it. Anything multiplied by 1 is same number. In this both 2, which 2 power has highest exponent? That is 3. Here we got 1. Here we got 1. Here we got exponent 3. Write that as over here. Okay. Comparison with these both. Here don't have 3, but the highest power for 3 is here 1 itself. So 2 2s are 4, 4 2s are 8, 8 3s are 24. LCM is 24, which is one and the same what we found here. 24 here with the help of prime factorization, 24 with the help of general understanding. Clear? Now, how to find the HCF? HCF. In this common, what is common in this both? 2 is common. Anything else is common. 1 is common. Correct? The least power. In this you need to write the least power. After finding the common, the least power. In this 1 and 1, the least power is, hence the HCF is 2. Okay. Into 1 also you can write 2 1s rest, which I have already written over here. HCF is 2. Hope it is clear. LCM, after finding the factors, simplify into the power fact in the form of a power 2 power 3. Compare the common in this. Okay, not common. Write whatever the numbers are here. I can be able to see here 2. I have written 2. I can able to see here 3. I written 3. I can able to see here 1. I have written 1. In comparison with this 6 and 8, I can see that 3 is the highest power. 2 has the highest power 3. So I have written 3 here. Then for 3 the highest power is 1 itself. Here we don't have 3. So I have written only once. Multiply this, you will get same 24. Hope you got this. Now we will come to the theorem 1.1. What is it? It looks like very lengthy. बहुत लंबा दिख रहा है. आसान है, बहुत आसान है. थोड़ा थोड़ा करके पढ़ेंगे. Every composite number. I told you what is composite number. The number which is divisible by more than 2 tables, or the number which are divisible, which has more than 2 factors. 9. Example, you take 9. Every composite number. Okay. 8 is a composite number. 8 is composite number. Correct? Because it goes in 2 table, it goes in 4 table, it goes in 8 table. Correct? It has more than 2 factors. 8 is a composite number. Every composite number can be expressed or factorized. Expressed and factorized. I am factorizing with the help of prime number. Can be expressed, factorized as a product of primes. So how? 8 I am writing as how? 8 I am writing it as 2 into 2 into 2 into 1. The product is multiplication. 2 into 2 into 2 into product of primes. Simple. Every composite number can be expressed as a product of prime numbers. 2 is a prime number, obviously. Every composite number, repeat with me. Every composite number can be expressed as a product of primes. Simple. That's what fundamental theorem of arithmetic says, which is theorem 1.1. And this factorization is unique apart from the order in which the prime factor occurs. Yeah, this is unique. Okay, this 2 either you can write here, this 2 either you can write it here. No difference. And this factorization is unique. Okay, it has unique numbers. This 2 is different, this 2 is different, this 2 is different, and this factorization is unique apart from the order in which the prime factor occur. Either I can write for this, either I can write this 2 here, this 2 here, no worries, these two both are 2's only. Either I can write 3 here, either I can write 2 over here. Okay, finally repeat with me once. Every composite number can be expressed or factorized. Every composite number can be expressed as a product of primes, as a product of primes, and this factorization is unique apart from the order in which prime factor occur. This might be asked in for 1 mark. Okay, this might be asked for 1 mark in exam paper. If it would be better if you revise it by seeing your textbook. Hope this introduction is clear. We'll go to the exercise 1.1. We'll start the exercise 1.1. The very first main of exercise 1.1 is express each number as a product of prime factors. The first question you have is 140. Okay, how to solve this? 140. 140. Check whether this number is even or odd. Okay, I've also already have told you. Okay, even numbers are keep in mind. Just remember this: even numbers are divisible by even numbers only. Okay, odd numbers are divisible by odd numbers only. Okay, keep this in mind. Now 0 is an even number, correct? We'll start with the smallest prime number, that is 2. The least prime number is 2. To how much? 2 7s are 14. 2 7s are 14. 0 same. Okay. Then again it's a even number. 2 3s are 6. 2 3s are 6. How much is remaining? 1. 2 5s are 10. Some students I have observed, they are totally new to solve this factorization method. The students who don't know, please try to understand. In 2 table, 2 1s are 2, 2 2s are 4, 2 3s are 6, 2 4s are 8, 2 5s are 10, correct? 7, nearest number for 7 is 6, correct? 2 3s are 6. What I took? 2 3s are 6. For 7, how much is remaining? 7 minus 6 is 1, which I kept on the head of this 0. So it became 10 now. It became 10 now. 2 5s are 10. 2 5s are 10. Hope this is clear. Hope this is clear. Further, we know the unit place has 5. It is not divisible by 2 table, correct? Neither it will be divisible by 3. How to check it? I told you. 3 plus 5 is how much? 8. 3 plus 5. 8 is not divisible by 3. Just now we have learned just now all the divisibility rules, right? 3. How to check the divisibility rule for 35? 3 plus 5 is 8, correct? If this number is divisible by 3, the whole number is said to be divisible by 3, but it is not possible by either by 2, either by 3. So how will we go with? How will we go with? We'll go with 5. We'll go with 5. 5 7s are 35. Then 7 you can keep as it is. Okay. What are the factors? 140 is equals to 2 into 2 into 5 into 7. Or you can further you can solve it. 2 power 2 into 5 into 7. This is a answer. Okay. Hope it is clear. Second, I'm going very slow so that you can understand the concept. If you feel that I'm solving very slow, you can skip the video or you can watch in 2x. Okay. 3x there is no option, it is a premium, but you can watch in 2x or 1.5x as per your तुम्हारी आपकी जैसी सहूलत है वैसे उसके हिसाब से आप सॉल्व करो. अब देखो, चलो next question. We got 156. यूनिट प्लेस पे कौन सा नंबर है? इवन नंबर है, तो इसको 2 के टेबल से सॉल्व करेंगे. 2 7s are 14. 2 okay, 2 into 6 12, 2 into 7 14. 2 7s are 14. 2 3s are 6. 2 3s are 6. Clear? 2 7s are 14. Sorry, 2 7s are 14. Okay, 2 7s are 14. 1 is remaining for 15. 2 8s are 16. 2 8s are 16. Sometimes even we go wrong. Understand. Okay, we understand. 2 7 14. 14 को कितना बचा? 15 के लिए कितना बचा? 2 7 14 है, 15 से सब्ट्रैक्ट करो 1. एक स्टूडेंट था जो हमें पढ़ा रहा था, उसको ऐसे ही सिंपल क्वेश्चन कुछ पूछा था मैं. 2 7 14, बचा कितना? सोच के बोला 2. कैसे? अरे कैसे सर? पता नहीं सर, समझ में नहीं. अरे समझो, इजी है भाई कॉन्सेप्ट, वो इतना इजी है. मट्ठूस बच्चा था वो, एकदम बदमाश मट्ठूस. मार मार के समझाने में बाद में समझा. ठीक है, चलो आप ऐसे तो नहीं होंगे, उम्मीद है. देन दिस इज इवन नंबर, करेक्ट. इवन नंबर इज डिविजिबल इवन numbers are divisible by even numbers only. Odd numbers are divisible by odd numbers. 2 3s are 6, 1 is remaining. 2 9s are 18, 2 9s are 18. Then 3 1s are 3, 3 3s are 9. Why didn't I go with 2? Because it is odd number. After that I have to think 9 is not divisible. If unit place has odd number, the whole number is not divisible of even table, so I have to go with 3 table. Okay, divisibility of 3, adding this both. 3 plus 9 is how much? 12. 12 is divisible by 3. Obviously I went 3 table. 3 3 1s are 3, 3 3s are 9. So 13 is a prime number which is not further, we can't solve it, so hence I can write it here. 156 is equals to 2 into 2 into 3 into 13. Further, if you want to solve, 2 power 2 into 3 into 13. This is a final answer. Hence therefore you can write it. Therefore the product of prime factors are this one. Clear? चलो नेक्स्ट क्वेश्चन सॉल्व करेंगे. तीसरा क्वेश्चन आपके स्क्रीन पर ये रहा, 3825. पहले तो सोचेंगे इवन प्लेस पे कौन सा नंबर है. अरे सॉरी, नॉट इवन प्लेस, यूनिट प्लेस पे कौन सा है? नंबर 5 है. करेक्ट. तो क्या हम डायरेक्टली 5 से जाएंगे? नहीं, पहले चेक करेंगे 3 से. 3 is a smallest prime number. 2 after 2 obviously we can't do it because in unit place के पास इवन नंबर नहीं है, तो इसको 2 से नहीं होगा. ये वाला टेबल क्या है? 2 से नहीं होगा. क्योंकि इवन नंबर जो है यूनिट प्लेस के पास इवन नंबर नहीं है. यूनिट प्लेस के पास इवन नंबर नहीं है. तो क्या करेंगे? 3 से ट्राई करेंगे. 3 का सिंपल डिविजिबिलिटी चेक कैसा है? 3 plus 8 कितना? 8 plus 3 11, 11 plus 2 13, 13 plus 5 18. Correct? Is 18 is divisible by 3? Is 18 is divisible? Obviously 18 is divisible. 3 1s are 3. How much are? 3 6 are 18. Correct? Then the whole number is divisible by 3. Let us go ahead. 3825. 3 1s are 3. 3 2s are 6. 3 2s are 6. Have a look carefully. The students who don't understand, I'm telling for those students, okay? I'm not telling for everyone. I know maximum of the students, it's very easy to solve this. The students who are totally dull in understanding, for them I'm trying to make you explain with the help of table. The nearest number for 8 in 3 table, for 8, 3 2s are 6, correct? That is 6. 3 3s are, if you take 9, it will be exceeding. अरे आगे बढ़ रहा है भाई, 8 से बाहर जा रहा है 9 नंबर. तो यही है नियरेस्ट नंबर. क्या करेंगे? 3 2s are 6. 3 2s are 6. कितना बचा? 7 8. 6 के बाद 7 8. तो 2 इसके सर पे लेंगे, तो ये नंबर क्या बन गया? 22. So what's the nearest number for 3 table now in 22? 3 7s are 21. कितना बचा 22 के लिए? 1. तो 1 इसके सर पे रखेंगे. 3 5s are 15. Next, can I further divide this number by 3? How to check? I told you, sum of all these numbers. 1 plus 2 3, 3 plus 7 10, 10 plus 5 15. Is this 15 is divisible by 3? Yes, obviously 15 is divisible by 3. 3 ones are 3 fives are. Hence the whole number is divisible by 3. 3, 3 fours are 12. 3 twos are 6. 1 carry. 3 fives are 50. Again, check this number is divisible by 3. 4 plus 2. 4 plus 2. 6. 6 plus 5. 11. But 11 is not divisible by 3. 11 is not divisible by 3. So hence I can go ahead with after 3 is 5. After 3 is 5. 5. 5 fives are 5 fours. 5 6 are 30. 5 7 are 30. 5 8 are 40. 5 8 are 40. How much is remaining? 42. 2. 5 5 are 25. Again, check whether this is divisible by 5. 3. No, because 8 plus 5 is 13. 13 is not divisible by 3. Go ahead with 5 table itself. 5 2s are 5 1s are 5. How much is remaining for 8? 3. 5 7s are 35. 17 is prime number. So I'll keep it as it is. Therefore, the product of prime factors are, the product of prime factors is 3825 is equals to 3 into 3 into 3 into 3 into 5 into 5 5 into 5 into 17 into 17. क्या करेंगे भाई, इसको सॉल्व करो फर्दर. 2 है तो 3.2 लिख दो, इंटू 5 2 बार है, इसको ऐसे लिख दो, इनको 17. So this is a final answer. Hope this I made it clear. If you have any doubts, please ask me in the comment section. I'm there to help you out. Okay. Anything if I have made wrong, try to help me out. Hope so I have not made anything wrong. It's very easy, students. It's very easy. The first chapter, real number, is very easy. If this question is not in your paper, irrationality question will be there. If irrationality is not been asked, this question will be there in your paper. Now we have a next question, 5005. How to solve this? 5005. Okay. Can we go ahead with 3 table? Can we solve it? If you do the addition of all of this, 5 plus 0 plus 0 plus 5, 5 plus 5, 10. Correct? 10 is not divisible by 3. Hence, the whole number is not divisible by 3. Correct? So, we'll go ahead with 5. 5 ones are 5 ones are 5, 0, 0, 5 ones are 5. Okay. Then, can we go ahead with 5 further? No, because the last digit which is over here, 1, it's not, if the unit place, have 0 or 5, we know well, 0 or 5, the whole number is said to be divisible by 5, correct? But we don't have 0 or 5 over here. So, what we will do is, we'll cancel solving by cancelling 5, okay? After 5, since it's an odd number, we have to go ahead with odd numbers itself. So, 1 is an odd number. So, which table we will be solving? After 5 is 7, correct? What is the divisibility of 7? How to check the divisibility of 7? The last number, double the last number, correct? 1 plus 1, 1 plus 1 is 2. 2, we have to divide, okay? The last digit not divide, so subtract 100 minus 2. 100 minus 2. What is 100 minus 2? 98, correct? Is it 98 is divisible by 7? 7 1s are 7. 7 1s are 7, correct? How much is remaining? 2. 7 4s are 28. 7 4s are 28. Yes, it is divisible. 14 is divisible. Okay, hope it is clear. Those people who is not understanding, I have already explained the divisibility rules for all of these divisibility rules. Okay, I have explained all of these in the starting of the video. Please go and watch that. 5, 7, 7 1s are 7 2s are 14. 7 1s are 7. How much is remaining? 3. I'll keep on the 0 on the head of this 0. So it becomes 30. 7 4s are 28. 7 4s are 28. How much is remaining? 2 is remaining, correct? So I'll keep on this head. So it became 21. This became 21. Okay. 7 3s are 21. 7 3s are 21. Check quickly whether 143 is divisible by 3 table. 1 plus 4 is 5. 5 plus 3, 8. It's not divisible by 3. How to check with 5? The even place doesn't have 0 or 5, so hence it is not divisible by 5 also. Then what can we do? Go ahead with 7. What to do? 143, double the last digit. I'll write it here. 143, double the last digit. 3 into 2, 6, correct? Subtract with 14. Subtract with 14. 14 minus 6 is how much? 8. 14 minus 6 is 8. So 8 is divisible. Is it 8 is divisible by 7? No. So we can't go ahead with 7. What is the next table? Then what's the next step? After 7, since it's an odd number, we have to divide with odd number itself. What is the next step? If not 3, if not 5, if not 7, then the next step is going ahead with 9. 9 table. How to find whether this number is divisible by 9 table? 1, 4, 3, right? Add up all. 1 plus 4 plus 3. How much? 1 plus 4, 5, 5 plus 3. 1 plus 4, 5, 5 plus 3, 8. Is it 8 is divisible by 9? No, it's not possible. It's neither divisible by 8, 7, neither 5, neither 9, neither 11, then 13. 13. I think I haven't taught you the divisibility of 13. Just let me quickly check how to, whether it is divisible by 13 table. 13, 13 ones are 13. 1 carry 13. Yes, it is divisible by 13. See, the option is, if it is not solving by 3, go ahead with 5. If it is not by 5, go ahead with 7. If not by 7, then 9, then 11. Check with this all. Then go ahead with 13. If it is not getting solved by 13 also, then we have options of other numbers, that is 15. Mostly 15 is not being used to solve the factorization method. Go ahead with, once check quickly 15, whether if the number is ending with 0 or 5. Okay, then only it will be divisible by 15 also. Okay, 15, then 17, mostly the 17. Okay, 19, then 23. 23. Okay, this is a step you need to keep in mind. So 13, 13 ones are 13. How much is remaining? 2. Okay, not 2. 13 ones are 13. 1. 13 ones are 13. So 11 is a prime number. Therefore 5005 is equals to 5 into 7 into 13 into 11. 13 into 11. This is a prime factors of 5005. Hope it is clear. Hope it is clear. I'm thinking to find how to find the divisibility of 13 to 15, 13 to 23 in the next video. I'll be coming up with all of these videos. How to identify 13 to 23, how to identify the divisibility factors, divisibility rules for those numbers. Next, we'll go ahead with this fifth one. 7429. 7429. Since it's an odd number, I will go with odd numbers only. Okay. 3. I'll go with 3. 7 plus 4. 7 plus 4, 11. 11 plus 2, 12, 13. 13 plus 9, 13, 7, 22. But 22 is not divisible by 3. 3 we can't do. After I add it up all and to see the number, I am getting 21, correct? I mean 22. 22 is not divisible by 3, hence the whole number is not divisible by 3, correct? Then 5, no, because the unit place doesn't have 0 or 5. 7, how to check with 7? Double the last digit, 7429. Last digits double, if you double 18. 18 minus 742. 742 minus 18. 12 minus 8. 4, 6, 11 minus 1. 9 minus 1. 10. 742 minus 18. 3, 12. 12 minus 8, 4, 3 minus 1, 2, 724. Check 724 is divisible by 724 divisible by 7. 7 is 7, 0, but 24 is not divisible. Neither it is getting solved by 3, neither it is getting solved by 5, neither it is getting solved by 7. Okay, neither 3, 5, 7. Then we'll check with 3, 9. How to check with 9? Quickly we'll go ahead. Add it up all of 7 plus 4 plus 2 plus 9, we are getting 22. Correct? 9 plus 2, 11, 11 plus 4, 15, 15 plus 7, 22. But 22 is not divisible by 9. Again, it is not divisible by 9 also. 11. Okay? 11. 11. How did I teach you the 11? Divisibility of 11. Divisibility of 11. Checking with odd numbers and even numbers, correct? 7, 4, 2, 9. Odd numbers, 7 plus 2 is 9. 9 plus 4, 13. 9 plus 4 is 13. 13 minus 9. 13 minus 9 is 4, but 4 is not divisible by 11. 4 is not divisible by 11. Or it is, we are not getting 0 also. We are not getting 0 also. This number is directly divisible by 17. 7, 4, 2, 9. Let me check with 17. 17 on the 17 into 7 4 is 28 to carry for 1 4 5 6 68, correct? 17 4 is 68. How much is remaining? 68. 6 is remaining, correct? 17 3 is how much? 51. So this is 5, 17 is 21, 2, 3, 1, 17 is 51, 62. 17 3 is 51. How much is remaining? How much is remaining? 9 here, 10, 11. 11 is remaining. 119. 119. 17 7s are 7 7s are 49. 4 7 are 7, 8 9 10 11. So this is divisible by 17. This is divisible by 17. 17 17 4 is 17 4 is how much? 17 4 is 68. 17 4 is 68. How much is remaining? 4, correct? 17 3 is 17 3 is 51. How much is remaining? 11. So this became 119. This became 119. 17 7 is 119. 17 7 is 119. Again, this is a special number wherein it is not divisible by 3, 5, 7, neither 11, neither 13, neither 7. It will directly go by 19 itself. Okay, 437 by 19. 19 ones are 19. 19 ones are 19. Okay, I mean not 19 ones are 19 twos are is 36. 19 twos is 36. How much is remaining? 4 is 7, correct? 19 fours are 96. 19 threes are how much? 9 threes are 27. 2 3 ones are 3 4 5 57. 19 ones 19 38. How much is remaining? 4, sorry, will come up here. 437 divided by 19. 19 ones are 19 twos are 18. 36, right? 2 ones are 2, 3, 38. Sorry, 38. 19 twos is 19 twos are 38. How much is remaining? How much is remaining? 5. 5. This became 57. 19 threes are 9 threes are 27, 51, 5, 57, correct? So this number is divisible by 19 only. See, if you want, you can check with this all number 3, 5, 7, 9, 11, 13. Okay, 15 and 17. None of these number is divisible. So hence I'll go ahead with 19 itself. 19 how much is 19 twos are 19 twos are how much? 38. How much is remaining? 39, 40, 41, 42, 43. 5. So I'll keep over here. So this became 57. So 19 3s are 57. 23 is prime number. 23 is prime number. So we'll keep as it is. Therefore, the product of prime numbers are prime factors are 7429 is equals to 17 into 19 into 23. Hope it is clear. Okay. Next main of your exercise 1.1, find the LCM and HCF and verify LCM into HCF is equals to product of two numbers. First, we will find what is LCM and HCF of this number. Then I'll come to this past verification part. Okay. 26. इधर लिख लो, थोड़ा छोटा लिखेंगे. 26 इधर 91. ठीक है, सही वन नंबर, करेक्ट. 2 1s are 2, 2 1s are 2, 2 3s are 6. Further we can't solve it since it's a prime number. Then 91. Can you go ahead with 3? How to check divisibility with 3? 9 plus 1 10. 10 is not divisible by 3. No, it is not possible with 3. 5 no. 7 9 last double the last digit 2. 2 subtracted with 9. 9 minus 2 is 7. Yes, 7 is divisible by 7 and this number is divisible by 7. 7 how much? I'll repeat it again. How to check with the divisibility of 91? Double the last digit. 1 into 1 plus 1 it is 2, correct? Subtract with this 9. 9 minus 2 is 7, correct? This last digit is divisible by 7 table. Hence the whole number is to be divisible by 7. 7 1s are 7. How much is remaining? 8 9 2. इसके सर पे रखेंगे, ये बन गया 21 और बचा क्या? 7 3s are 21. 7 3s are 21. Now what are the factors? Therefore 26 is equals to 2 into 13 and 91 is equals to 7 into 13. 7 into 13. How to calculate LCM? LCM is equals to, see what kind of number, जितने तरीके के numbers तुम्हें दिख रहे हैं वो एक एक बार लिख लो सभी. जितने तरीके के number, different, I write it here, different numbers, write it all once. Write it all once. What are the different varieties of numbers we can see, write it all once. Okay, let me clarify. 2 I can see, 13 I can see, correct. 7 I can see, so 13 already have written. 13 already have written. अलग 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 हिंदी में बोला जाए, अलग 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 जो भी जो भी जो भी पक्षी या बर्ड बर्ड दिख रहा है, ये सभी एक बार लिख लो, ठीक है. इसका इन दोनों में कंपेयर करो किसका हाईएस्ट पावर है. 2 है, इसके पास 2 नहीं है. ओके, इसका हाईएस्ट पावर 2 का 1 ही है, तो 2 का 1 1 होएगा. इसका भी 1 है, इसका भी 1 है. कंपेरिजन ऑफ 13 एंड 13, हाईएस्ट पावर इज 13 पावर 1 only, highest power. 17 we have only one number, so it has only one highest power. Okay, simply if it was 13 into 13, for 13 into 13 we would have written 13 square. Okay, we would have written 13 square, and here comparison of these two we would have taken 13 power 2, which is highest power 2. Okay, but in this case we don't have it. Okay, 13 power. Hope it is clear. Now we'll find the multiplication of this. 7 2s are 14. Seven twos are 14 into 13. 4 threes are 12, 1 carry. 3 ones are 3, 4 into 4 ones are 4, 1 ones are 1. 2 plus 4, 8, 1. 182. So therefore the LCM is 182. 182. How to find the LCM? How to find the HCF? See, in this both the common is 13. Okay, in this both the common is 13. Hence HCF is 13. And the least power we have only 1 itself. So we have 13. HCF has 13. So what is it telling to verify? LCM into HCF is equals to product of two numbers. Product of two numbers. Where A is what? Or A is 26 and B is 91. A is 26 and B is 91. इन दोनों को सब्स्टिट्यूट करेंगे, क्या आएगा? 182 इंटू HCF कितना है? 13. A कितना है? 26. B कितना है? 91. इसको मल्टीप्लाई करो, ये और ये आंसर सेम होना चाहिए. कितना होगा? 182 इंटू 13 लेकर मल्टीप्लाई किया 2366 2366 multiply this 2366. Therefore LHS is equals to RHS. LHS is equals to RHS. Hope this is clear. We'll go ahead with the next question. क्या बोल रहा है हमारा क्वेश्चन? 510 and 92. Okay. 2 table it is divisible. 2 2s are 4, 1 carry. 2 5s are 10, 1 carry. 2 5s are 10. We'll check with 3 whether it is divisible by 3. How to check? Add up all of this. 2 plus 5 7, 7 plus 5 is 12. 12 is divisible by 3. Yes, it is divisible. I will go with 3. 3 5 3 6 are 3 8s are 24. 1 carry. 3 5s are 15. 85. Is it 85 divisible by 3 table? 8 plus 5 is 13. No, it's not divisible by 3. I'll go ahead with 5. Since unit place has 5. Either 0 or 5 we need to have in a unit place. We have 5 here. It is easily divisible by 5. 5 1s are 5. बचा कितना? 3. 5 7s are 35. और इसको सॉल्व करेंगे. 2 how much are 2 4s are 8. 1 carry 2 6 are 12. 2 2s are 4. 2 3s are 6. 23 is a prime number. So what are the factors? 5 into 2. 2 into 3 into 5 into 17. What are these factors? 92. 2 square into 23. Can I write like this? 2 power 2 into 23. Okay. गौर से देखो एलसीएम कैसे फाइंड करेंगे. जितने तरीके के नंबर दिख रहे हैं हमें सब एक एक बार लिख लो. 2 दिख रहा है हमें, 3 दिख रहा है हमें, 5 है, 17 है. 2 को हमने लिख लिया है, 23 को लिखा है नहीं, एक बार लिख लो. सब एक बार लिख लो. हर रकम का एक एक बर्ड लिख लो. और हर चीज का एक एक पक्षी लिख लो. ओके. नाउ See the highest power in this. For 2, which is the highest power, we have 2 square, correct? For 3, we have only 1. Okay. For 5, only 1. For 17, 1. For 23, only 1. In comparison of 2 and 2 here, the highest power for 2 is 2 power 2 in this 592 LCM factors, LCM and HCF factors. The highest power for this 2 into this is nothing but 1. In comparison with powers, highest power is 2. So if you multiply this, 2 square is 4 into 5 3 is 15 into 17 into 23. 15 4s. Let us multiply this. I'll come with this. Let us go with HCF now. So 2, what is common in this both? Anything is common in this both? What is common? 2 is common, correct? 2 is common. What is the least power in this? सबसे छोटा वाला power एकदम तो 1 है, ठीक है. इन कंपैरिजन छोटा वाला. LCM में हाईएस्ट पावर लेंगे और HCF में लोएस्ट पावर लेंगे, लीस्ट पावर लेंगे. So the HCF is 2. Okay. After we multiply, we'll get the answer for this. Let me check the 15 5 was 22 4 1 5 6 60, then 17 into 23. So these are 21 to calculate 4 5 into 10 to the 41 1 2 3 1 5 plus 1 9 391 390 1 into 6 6 on the 6 6 54 6 is 18 18 plus 5 23 2 3 4 4 4 6 0. We are getting 2 3 4 6 0. Okay, we need to find the LCM into HCF. LCM into HCF is equals to product of numbers. We got A into B as, okay, 510. See, initially you mention here, let A is equals to 510 and B is equals to 92. Into 92, LCM what we have got, 23460 into 2. After you multiply, you'll get some answer. After you multiply here, you'll get some answer. This will be the final verification. Okay. To multiply, we'll multiply this. Quickly we'll multiply 23460 into 2. 2 0 6 2 12 1 3 4 2 8 9 3 2 6 2 2 4 46920 46920 50 into 92 2 0 0 2 1 0 2 5 10 into 9 0 0 9 1 9 into 9 5 35 0 2 9 6 3. Hold on. 5 10 0 2 1 2 5 10 then into 9 0 0 9 9 5 5 9 45 5 9 45 46900. It is same 46920. Therefore LHS is equals to RHS. This completes the second question. Then we got to final question, that is third question. We'll be solving that. We'll solve this question. 336. 2 1s are 2, 1 carry. 2 6s are 12, 1 carry. 2 8s are 16. 2 8s are 16. 2 4s are 8. 2 4s are 8. 2 2s are 4. 2 2s are 4. 2 1s are 2. 3 7s are 21. 7 is not used. 54 को कैसे solve करेंगे? 2 1s are 2, 1 carry. 2 7s are 14. I mean 2 2s are 4, 1 carry. 2 7s are 14. 3 3s are 9. 3 9s are 27. 3 3s are 9. Then 3 1s are 3 also you can multiply. How can I write this? 336 as 1 2 3 4 2 power 4 into 3 into 2 into 7. Clear? Then 54, how can I write? 54 1 2 3 2 into 3 power 3 2 into 3 power 3. इधर गौर से थोड़ा ध्यान दें, एलसीएम कैसे लेंगे. सब नंबर एक एक बार जो है लिख लेंगे. 2 हमें दिख रहा है लिख लेंगे, 3 दिख रहा है लिख लेंगे, 7 लिख लेंगे, 2 ऑलरेडी लिख लिए हैं, 3 ऑलरेडी लिख लिया, अभी जरूरत कुछ भी नहीं है. ठीक है. कंपेयर दिस बोथ. अगर इन दोनों को कंपेयर करेंगे 2 और 2 को, इसका हाईएस्ट 2 का हाईएस्ट पावर कितना है? 4. और लिख लो. ठीक है. C3 any comparison is there? Yes, we got the 3 over here. Okay, highest power for 3 is 3 power 3. एक बार लिख 3 power 3. So in this comparison nothing is there. 7 power 1. Let me repeat again. Read all these number ones. 2 into 3 into 7, 2 into 3 into 7. 2 is already written, 3 is already written, it's repeated. We need to write only one time. ठीक है, एक ही बार लिखना है. बाद में कंपेयर करेंगे, जिसका हाईएस्ट पावर होगा वो लिख लेंगे बस. इन दोनों में कंपेयर किया, हाईएस्ट पावर किसका है, 4 का है, इधर लिख लिया. इन दोनों को कंपेयर किया, इसका हाईएस्ट पावर कितना है, 3 है, लिख लिया. If you multiply this, 2 to the 4 to the 8, 2 to the 4 to the 8 to 2 to the 4, 4 to the 8, 8 to the 16 into 3 3 is 9, 3 is 27 into 7, correct? 27 into 7, 7 7 is 49, 4 9 to the 7 2 is 14, 14 plus 4, 18 189 into 189 into 16, 16 is 54, 5 1 8 6 is 48, 48 plus 5, 50, 48, 53, 5, 6 1 is 6, 6 plus 11 into 9, 8 1, 9, 8 9 10, 1 plus 1 2 3, 3024, 3024 is the LCM. See how to find the HCF. HCF. What is common in this both? 2 is common, correct? What is the least power? इस पे जो हाईएस्ट पावर लिया गया 4, इसका लीस्ट पावर लेंगे 1. सिंपल. इनटू व्हाट इज कॉमन इन दिस बोथ? 3 कॉमन है, 3 कॉमन है. इसका हाईएस्ट पावर कितना है दोनों का? 3 है. लोवेस्ट पावर, लीस्ट पावर 1 है, तो 3 पावर. सो 2 3 is 6, 2 3 is 6. Okay, HCF is equals to 6. HCF is equals to 6. Now, as per our verification, what to do? LCM into HCF is equals to product of two numbers, or we can say into B. LCM we got 3024, into HCF I got 6. Product of numbers 336 into 54. Let us solve this quickly. What to get? What will be getting answer? 3024 into 6 plus 24 to get 6 plus 12, 12 plus 2, 14. So 1 0 0, 1 6 3 6 3 is 18. 1 8 1 4 4, 1 8 1 4 4. Here also we need to get the same. 1 8 1 4 336 into 54. 6 4 is 24. 4 is 12. 14. We'll carry 4 is 12, 13. Into 6 4 is 24. 6 4 is 30. 4 is 15. 18. 1 carry 15. 16. 4 is 4. 8 plus 3. 8 plus 3. 11 1 carry 6 7 8. 1 8 1 8 1 4 4. Hence LCM into HCF is equal to product of two numbers. You can write it. Concluded. After conclusion, you write it. LHS is equals to RHS. Okay. Hope it is clear. We'll go with the next question. LCM and HCF by prime factorization method. 12, 2 6 are 12, 2 3 are 6. Okay. For the reconcile, 3 5 are 15, then 21. 7 3 7 are 21, correct? 12 is equals to 2 square into 3, correct? 15 is equals to 3 into 5, then 21 is equals to 3 into 7, 3 into 7. So LCM, what are the different numbers I can see? 2 I can see, 3 I can see, write it once, 3 already written, 5 3 already written, 7, correct? Comparison of this all, 2, highest power for 2 is 2. Okay, highest power for in this all only 2 we have only once, so highest power is 2 only. Okay, we have written once. 3 3 3, the highest power is 1 itself, I'll write it 1. Then 5, only 1 we have, I'll write 1. For 7 I have only 1 highest power, I'll write it once. 2 square is 4 into 5, 5 3 is 15, 5 3 is 15 into 7, 7 4 is 28 into 15, 8 5 is 44, 5 2 is 10, 10 plus 4, 14 into 8 1 is 8, 2 1 is 0, 8 plus 4, 12, 1 carry 2 3 4, 420. 420 is the LCM. 422 square, so 40. 420 is the LCM. Then HCF is equals to, what is common in this board? 3 is common. 3 is common. So the least power is also 1. So 3 is the HCF. This is the LCM. Next, we got the question 17, 23, and 29. See carefully, 17 is a prime number, so it is 17, once the 17 itself. 23 is also a prime number. What is prime numbers? We know very well. The numbers which have factors only one. It is divisible by only one and itself. 23 is neither divisible, is not divisible by any other table except by itself. Okay, only 23 into 1 is 23 ones are 23 only. 23 into 1 is 23. Okay. Then we have 29. 29 ones are 29 is also prime number. See, LCM is equals to 17, not LCM, factors we will write. 17 is equals to 17 into 1. 23 is equals to 23 into 1. 29 is equals to 29 into 1. What is common in this both? Write all of this number once. 17 is there, 23 is there, 29 is there. But we don't have highest power for all of this. The highest power is 1 itself. You don't need to write also. Okay. Multiply this all, you will get the LCM. What is the HCF? What is the HCF? 1. For common everywhere, the HCF is 1. After you multiply this, what we will be getting? Quickly we'll find here. 70 into 23. 73 is 21, 2, 3, 1, 3, 4, 5 into 20, 41, 1, 2, 3, 1, 391. 391 into 391 into 29. 81, 27, 27, 30, 35 into this is 1. 2 ones are 2, then 1 into the 8 is carry, 3 2s are 6, 7, 9, 2 plus 1, 3, 8, 31 carry 7, 8, 8 plus 3, 11. 11339. 11339. Okay. Hence the LCM is, hence write it here. Therefore LCM is 11339 and HCF is equals to 1. We'll go ahead with the next question. 8, 2 4s are 8, 2 2s are 4, 2 1s are 2, 9, 3 3s are 9, 3 1s are 3. Okay. 25 is not divisible by 3, we will go with 5. 5 5s are 25. 5 1s are 4. What are the factors for 8? 2 power 3. What is the factor for 9? 3 power 2. 5 into 5. 25 is equals to 5 into 5 or 2. So how to find the LCM? LCM is equals to, write all of these number ones. 2 into 3 into 5. See, in this, for 2, the highest power is 3 itself. We don't have 2 over here. If it was 2 power 4, assume if it was 2 power 4, we would have taken 2 power 4 over here, correct? But we got only highest power is 3. So I'll write it 3 over here. Comparison 3, only we have only 3 here. So you don't have either here, either nor here. So 3 square, the highest power is 3 square. 5 square, we have only 5 square highest power. So LCM 4 2 are 4 2 are 8 into 3 3 are 9 into 5 5 are 25. 8 9 are 8 9 are 8 9 are 72 into 25. 72 into 25. Okay, we'll get the answer over here. So let us find the HCF first. What is common in this both? Nothing is there. 1 1 1 is there. Okay, I'll write it here. 1 into 1 into 1. So the common is 1. So I'll write it over here. The HCF is. Let me quickly find the answer for this. 72 into 25. 5 2s are 10, 1 carry 5 7 5 are 35 36 into 2 2s are 4, 7 2s are 14. 0 6 plus 4. 10 1 carry 4 7 8 1800. 1800. Therefore LCM is equals to 1800. HCF is equals to 1. HCF is equals to 1. Because the next question, wherein they have given Fourth question, HCF 306, 306 and 657 is 9, and LCM is 306 and 657, which is what they have told to find. Okay. Before getting into this, I'll tell you the relation between HCF and LCM. There is a relation between the HCF and LCM. What it is? HCF into LCM is equals to product of numbers. Okay. It's very important topic. It's very important concept. HCF into LCM is equals to product of two numbers. The product of two numbers, we can assume this as A and B. A into B. Okay. Repeat with me. Relation between HCF and LCM is given by HCF into LCM is equals to product of two numbers. HCF into LCM is equals to product of two numbers. See here, they have given HCF. HCF of this product of two numbers. Here the product is A is 306 and B is 657. A is 306, B is 657. Correct? They have given the product of two numbers as 9. HCF they have given. This given. Okay. We need to find the LCM. We got to find the LCM. Okay. In this case, if they have provided either the LCM or the HCF, okay, one value if they provided, we use this concept. HCF into LCM is to product. Let us apply this. HCF into LCM is equals to product. I'll write in A into B. HCF they have given what? 9. We got to find LCM. A, we know A 306 into what is B 657. LCM is equals to 306 into 657 upon multiplication goes to division. Slowly we'll cancel this. 3 3s are 9, 3 1s are 3, 0, 3 2s are 6. Then 3 1s are 3, 3 table it will cancel to 3 3s are 9, 1 carry, 3 4s are 12. What did we left with? LCM is equals to 34 into 657. 34 into 657. Let's quickly calculate here. 34 into 657. 7 4s are 28, 2 carry, 7 3s are 21, 22, 23. Into 5 4s are 22 carry, 5 3s are 15, 6 is 17. Into 6 4s are 24, 2 carry, 6 3s are 18, 19, 20. 8, 3, 7 plus 4, 11, 12, 13. 1 carry, 1 plus 1, 2. 2, 2, 3, 3, 8. Therefore, LCM is equals to 2, 2, 3, 3, 8. Hope this is clear. It's very easy concept. Whenever they give HCF and the product of two numbers, you have to put the values, put the formulas. LCM HCF into LCM is equals to product of two numbers A into. In this case, they have asked to find a LCM. In some cases, they also tell to find the HCF. You have to apply the same concept. If they told to find the one product of one number they'll give sometimes. You have to find B. Okay. The one number will be something. They'll be give value. LCM and HCF also they'll give value. If one unknown term is told to find, you got to find either A either B. Anything. Hope this is clear. We'll go to the next question. We go to sixth question. Explain why these two numbers are composite numbers. We know very well what is composite number. The number which is divisible by more than two factors. Assume take an example 8. 8 is divisible by more than two factors. Which tables it will go? 2 table, 4 table, not 5, not 6, not 7, 8 table. Correct? 2, 4, 8. More than two factors. It has more than two factors. Those kind of numbers are called composite numbers. We know very well. He is telling whether these given numbers is composite number or what, we have to check. But observation, अगर इसको ऑब्जर्व किया जाए कुछ कॉमन निकाल सकते हैं क्या? हाँ, 13 कॉमन काट सकते हैं दोनों में. इसके पास बचा क्या यहाँ से यहाँ तक 7 into 11. इसके पास क्या बचा? बाहर 13 आ गया तो 1 बचा है ना. 13 that implies 13 into 11 7 77 plus 1 78. 13. Okay. Can you further solve this? 13 into 78. Can we solve it? 78 further, if we solve the factors, 2 3s are 6, 1 carry, 2 9s are 18. Then 2 table it will not go, then 3. 3 1s are 3, 3 3s are 9. Correct? Now, if I pair it, 13 into 2, 2 3s are 6, I'll write 6 into 13. 2 3s are 6. Or else you can write 2 into 3 also. See, these numbers, this given expression, this is the expression. What I can declare, the given expression, what it is, 7 into 11 into 13 plus 13 has the factors 13 and 6. 13 and 6 has factors 13 and 6. Also, you can write 13, 2 and 3. Anything is also. Therefore, it is a composite number. Hope it is clear. कुछ नहीं, सॉल्व कैसे करेंगे? देखो, कुछ कॉमन है, 13 और 13 कॉमन है, 13 13 को बाहर निकाल लिया, बचा क्या? 17 इंटू 11 बचा है इसके पास, 13 तो बाहर है, इसके पास क्या बचा? नथिंग इज देयर, 1. इसको ऐड मल्टीप्लाई कर लिया, 11 7 77 प्लस 1 77 प्लस 1 78. ठीक है, हमारे को ये मिला. इसको हम फर्दर हम क्या कर सकते हैं? सिंप्लीफाई कर सकते हैं, फैक्टर्स बना सकते हैं. अगर फर्दर हम सिंप्लीफाई किया तो इसका फैक्टर्स क्या निकला? 2 इंटू 3 इंटू 13. इसको हम मल्टीप्लाई किया, 13 इंटू 6 इंटू 13. So we got the factors, okay? More than 2 we got the factors, hence the given expression is a composite number. Similarly, this is the second question. We will go ahead the same way. What thing we can take common out here? Anything? 5 and 5 we can take common. Agar 5 is common, that explains 5. If we take common out, what it remains? 7 into 6 into 4 into 3 into 2 into 1. Plus, if you take common out, remaining is 1. If I multiply these all, what I'll be getting? 3 2s are 6 here. 6 4s are 24. 24 into 7 6 are 42. 4 2s are 8. 4 4s are 16 into 2 2s are 4. 4 2s are 8. 8 6 plus 4 10. 1 8 plus 1 9 10. 1008. 5 1008 plus 1. 5 into 1009. After we multiply, we get 1008 plus 1, which is 1009. Here, if you observe, since 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 can be expressed as product of primes. This expression can be expressed as the given expression can be factorized as product of primes. Therefore, I can tell it can be. Therefore, it is a composite number. See, 1009. This cannot be further. Factorized, because this point also you can include if you want it. Therefore, here 1009 cannot be further factorized. Hence, this obviously, if we can't further factorize it, but we can tell that this has two product of primes. Okay, more than one. It has more than one factors for this given expression. Hence, therefore, it is a composite number. Clear? Why it is this not is further divisible? This number is not divisible because it's a prime number. You know very well, prime numbers are not those numbers which cannot be factorized more than one. Okay. So this completes both the questions. We'll go to the final question, which is the 7th question, the word problem. We got the 7th question. Okay. There is a circular path, it seems. There is a circular path. Okay. Where Ravi and Sonia is standing, or Sonia and Ravi is standing. Assume this is Sonia and this fellow is Ravi. Okay. They are starting in the same position and at the same time they'll start running around the circular path. Okay. At the same time same time, okay, same position and same direction, same direction, same direction they are going. Here in the question they have given Sonia takes 18 minutes, 18 minutes to go around the circular path and come back to the starting point. Okay, while Ravi takes 12 minutes. How many? 12 minutes to come back to the starting point again. सोनिया यहां से स्टार्ट कर रही है, पूरा सर्कुलर पाथ का एक राउंड मार रही है, कितने मिनट ले रही है? 18 मिनट. ठीक है, वही स्टार्टिंग पॉइंट पे रवि खड़ा है, स्टार्ट हो रहा है, पूरा पूरा राउंड मार के घूम के एक राउंड पूरा घूमा, तो कितने मिनट ले रहा है? 12 मिनट. नाउ द क्वेश्चन कम्स हियर, at what time they will meet each other, after how many minutes they'll again come back to the original position. See here, to identify whether this question is solved by LCM or HCF, that's a big question comes here. ठीक है, अगर सोनिया को ये पूरा राउंड पूरा मारने में 18 मिनट लग रहा है, मतलब यहां पहुंचने में उसको 9 मिनट लगेगा. ठीक है, सी आई एम मेकिंग ट्राई टू अंडरस्टैंड द लॉजिक ऑफ दिस. अगर यहां से 0 से पूरा में घूमने में 18 मिनट लग रहा है, तो आधा राउंड घूमने में 9 मिनट लग रहा है. ठीक है, 9 का आधा मतलब यहां पे समझो 4 मिनट, 4.5 मिनट लग रहा है. ठीक है, रवि को यहां तक पहुंचने में 6 मिनट लग रहा है ना, तो आधा, इसका आधा, मतलब यहां पे पहुंचने में 3 मिनट लग रहा है, यहां पे पहुंचने में 3, ये पॉइंट पे पहुंचने में 3 मिनट लग रहा है रवि को, और यहां पे पहुंचने में 6 मिनट लग रहा है. ऐसा कौन सा टाइम है जहां ये दोनों एक साथ वापस यहां पे मिलेंगे, वापस स्टार्टिंग पॉइंट में? दैट्स द क्वेश्चन. नाउ if you think carefully, do you need to do LCM or HCF? I'll show you the trick, simple trick. अगर गिवन से, जो गिवन क्वेश्चन है, गिवन से हम चाहते हैं छोटा वाला वैल्यू, छोटा वाला वैल्यू, गिवन से हम अगर चाहते हैं छोटा नंबर का वैल्यू, उसको हम लेंगे HCF. अगर गिवन नंबर से हम एक्सपेक्ट कर रहे हैं बड़ी वाली वैल्यू, तो क्या लेंगे? LCM. दिस कीप इन माइंड. इट्स वेरी इंपॉर्टेंट. अगर ये समझ में आएगा तो पूरा क्वेश्चन सॉल्व कर लेंगे. अगर एलसीएम लेंगे, इस क्वेश्चन में अगर गौर करेंगे, अगर इस 18 और 12 का अगर हम HCF लेंगे, अगर इसका HCF लेंगे, एक छोटी वैल्यू आएगी, है ना? क्या अगर इन दोनों का HCF लेंगे तो हमें आएगा 2, मान लो 2 और 3 आएगा. क्या हमें ये चाहिए 2 और 3? नहीं चाहिए, क्योंकि अगर ऑब्जर्व करेंगे तो इनको घूमने ही में ही पूरा 18 मिनट ले रहा है. 2 मिनट में तो यहां पहुंच रहे हैं, 2 या 3 मिनट में ही कहीं पहुंच रहे हैं. बिकॉज वी आर गेटिंग वेरी स्मॉल वैल्यू इन फाइंडिंग HCF. हेंस HCF इज नॉट यूटिलाइज्ड हियर टू सॉल्व दिस प्रॉब्लम. हमें चाहिए क्या? थोड़ा बड़ा वाला वैल्यू, उसके लिए हम यूज करेंगे LCM. इसलिए यूज करेंगे LCM. लेट मी रिपीट इट अगेन. If you do solve with HCF, the value we are getting is 2 or 3 something. We will get a smaller value. But by the logic understanding, we don't want 2 or 3 minutes. 2 और 3 मिनट में यहीं पे हैं, और यहाँ पे नहीं मिल रहे वो लोग. ये पॉइंट में 3 मिनट पे ये बंदा मिल रहा है, 4.5 मिनट में यहाँ मिल रहा है, तो ये बंदे ऊपर नीचे हैं कहीं पे. So we don't use this word. We need a little bigger value. That's why you go ahead with LCM. Hope this concept is clear. This logic understanding I have made more complicated for you, I believe so. But for understanding this concept, To solve all the word problems, you got to use this concept. If you do use this concept, you'll clearly solve this question. Clearly solve these questions. It's very easy. Let us solve now. 18, 18, 2 9s are, 3 3s are, 3 1s are. Then 12, 2 6s are, 2 3s are. Okay. What are the factors? Therefore, 18 is equals to 2 into 3 into 3, 2 into 3 into 3. Can I write this as 2 into 3 square? Then 12 is equals to 2 square into 3. How to take the LCM? LCM is equals to, how to take the LCM? What are the numbers, different numbers I can see? 2 into 3. अलग अलग नंबर जो दिख रहा है मुझे 2 and 3 का, इन दोनों में अगर कंपेयर किया जाए तो हाईएस्ट एक्सपोनेंट 2 का हाईएस्ट एक्सपोनेंट पावर 2 है, तो 2 पावर 2. If you compare this 3 and 3, the highest power for this is 3 power 2. The highest power is 2. Okay, so I'll write it 2. So 2 square is 4 into 3 square is 9. 9 4s are 36. 9 4s are 36. So LCM we got 36. Okay. Therefore they will meet after 36 minutes at the starting point. Conclude. Therefore they meet after 36 minutes at the starting point. Hope it is clear. We'll move to the next exercise 1.2. Exercise 1.2. Before getting into exercise 1.2, we learn an important theorem from your chapter point of view, which is, it states if P divides a square, P will also divide A. Very important concept. Let us take an example. P divides A square. What is it telling? If P divides A square, P will also divide A. Take an example. Let P is equals to 3 and A is equals to, we'll take 6. Okay. P divides A, meaning if you take P value 3, if 3 is dividing 6 square, A square, what is 6 6 are 36, correct? If P is dividing this one, if P is dividing this number, 3 1s are 3, 3 2s are 6, we're getting 12. P will also divide A. This number P will also divide this number A. 3 1s are 3 2s. You can see it is getting divided. Obviously, सिंपल भाषा में P डिवाइड, अगर P डिवाइड करेगा A स्क्वायर को, तो P A को भी डिवाइड करेगा. This is a simple thing we will be solving for the irrationality. Okay, we'll quickly move to the question number 1, which is root 5. Prove root 5 is a irrational number. Okay, prove root 5 is irrational number. Okay, to prove this number irrational, we'll go with the contradiction method. Okay, proof by contradiction. Let root 5 be a rational number. We'll prove this with the help of a rational. We'll assume that root 5 is a rational number. We'll prove this with the help of contradiction. Okay. What is this proof of contradiction? I'll tell you at the end after solving the question what is exactly it is. Okay. We're assuming root 5 is a rational number. We know that to be a rational number, it is in the form of root 5 rational number is in the form of p by q, correct? I'm assuming root 5 in the form of rational number. We know that the condition where q is not equals to 0 and p and q are co-prime. P and q are co-prime. What is meant by co-prime? We know that those numbers which has HCF 1 numbers, the numbers which have HCF is equals to 1. HCF 1. Okay, we are considering the condition P and Q should have the HCF 1. Meaning what? Assume if we take 2, P as 2 and Q as 3. 2 by 3, correct? This HCF is 1 and here the HCF is 1 because it's a prime numbers. We are considering that kind of example if these two numbers are co-prime to each other. Clear? Okay. Now, if we go ahead, squaring on both sides, squaring on both sides. What will be getting on squaring on both sides? Root 5 square divided by p by q whole square. Square and root get cancelled. 5 is equals to p square by q square. 5 square by square belongs to p also, square belongs to q also. Okay. And what I'll do? Q square is equals to p square by 5. P square by 5. If you see carefully, I can tell that 5 divides p square. Therefore, 5 divides p square. 5 divides p square. With the help of that theorem, we know that if p divides a square, p also divides a, correct? I can write with the help of this 5 also divides p. 5 also divides p. If 5 divides p square, 5 will also divide p. 5 will also divide p. 5 also divides p. 5 will also divides p. Okay, 5 will also divides p. See here, after we divide this, we'll get some value, correct? We'll get some value. Anything after dividing this, as per the condition, as per the theorem, 5 also divides p, correct? Let us say this answer will be getting m. We'll assume this as let. Okay. What did we assume? Let p by 5 is equals to m. If you cross multiply, p is equals to 5m. Let us consider this as equation 1. Let us consider this as equation 2. Okay. Put 2 in 1. What will be getting? P value 5m. Q square is equals to 5. In place of p, I have to put 5m. 5m whole square upon 5. Further, if you solve this, q square is equals to 5 5s are 25 m square upon 5. 5 1s are 5 5s are 25. Q square is equals to 5m square by 1. Further, how can we solve this? Q square upon 5 is equals to m square. Q square is equals to q square by 5. Q square by 5 is equals to m square. If you observe this, 5 divides p square, 5 also divides p. Similarly, we can see here. Similarly, if you see carefully, okay. Similarly, if you see carefully here, 5. Therefore, 5 divides q square. 5 divides q. 5 divides q square. 5 divides q. Something 5 divides q. Okay. 5 divides q. We'll take this value as n. Something we'll be getting the value. Okay. Let it be let 5 divides q. 5 divides q. We'll assume the value of n. Okay. Cross multiply, q is equals to 5n. Q is equals to 5n. Here, by comparing these two values, okay, I assume this equation 3. Okay, here I'll write P by Q is equals to 5m by 5n. 5m by 5n. Okay, we assume that this is co-prime. These two numbers are co-prime. Okay, which has HCF 1, but we're getting the common factor 5. We're getting the common factor 5. Conclude here. Therefore, it has common factor 5 as a common factor. 5 as common factor. This leads to contradiction. So this is what the contradiction. Okay, जो हमने सोचा था वो गलत निकला. हमने सोचा था ये जो प्योर क्यू था कोप्राइम था, गलत निकला. This leads to contradiction. Our assumption is wrong. Therefore, root 5 is irrational. Let me quickly tell this how to solve within a minute. First, assume पहले root 5 को contradiction से prove करेंगे. Let root 5 is a rational number. Root 5 is in the form of p by q, where q is not equals to 0. We know the condition. And p and q are coprime. What are the coprime? The coprime are those numbers which has HCF 1. Okay, I shown an example how 2 and 3 has 2 and 3. These two numbers has HCF 1 because these two numbers are prime numbers. We assume this. Okay, squaring on both sides. After square on both sides, square and root get cancelled. We get 5 p square by q square. Okay, I took interchange this q square p square by 5. We know that by theorem, if 5 divides p square, 5 also divides p. 5 divides p square, 5 also divides p. With the help of that, 5 also divides p. We will be getting some value. I'll assume that as m. We'll assume that as 1. After cross multiplication, p 5 into 5 cross multiply, p is equals to 5. I am assuming that equation number 2. Put 2 in 1. The value of p I'll put in equation number 1. So it will be q square is equals to p square by 5. 5m square by 5. 5 5s are 25. 5 remain as it is. 5 1s are 5 5s are 25. Q square is equals to 5m square. So q square, this m square I'll take 5, I'll take it down. So it will become q square by 5. If you see carefully this and this, it looks same. It looks similar. What I can tell, 5 divides q square, 5 divides q square, 5 also divides q. The same thing I took 5 divides q. I'll take that some value we'll be getting some value. कुछ भी मिल सकता है. Okay. Whatever the value I considered, a cross multiply q is equals to 5. Okay. If we compare equation number 2 and 3, p by q is equals to 5m by 5n. 5m by 5. We're getting the common 5. We're getting the common factor, common number 5. It has a common factor 5. This leads to contradiction. Our assumption is wrong. Root 5. Sorry भाई, जो भी है हमारी सॉरी है, हमारी तरफ से ये कॉन्ट्रडिक्शन हो गया, हमारी तरफ से गलती हो गई, माफ कर दो. रूट 5 हमारा जो इरेशनल तुम मांग रहे थे वही इरेशनल है. Simple. Okay. Hope this is clear. I will go to the next question. We go to the next question. 3 plus 2 root 5 by contradiction. Proof by contradiction. Let 3 plus 2 root 5 is equals to p by q. Where same condition you got to write, where q is not equals to 0, p and q are coprime. 2 root 5 is equals to P by Q. This 3 will go this side, minus Q. Okay. 2 root 5 is equals to P minus cross multiply 3Q upon Q. Multiplication goes to division. Root 5 is equals to P minus 3Q upon 2Q. Root 5 is equals to, separate this, P by 2Q minus 3Q by 2Q. Okay. 3Q by 2Q. See, this is an irrational number. Correct? This is a rational number. This is a rational number. Minus. This is a rational number. Rational minus rational is rational only. Rational minus rational is rational number. Okay. Therefore, irrational is not equal to rational. What I can say? Irrational is not equal to rational. Therefore 3 plus 2 root 5 is irrational. So by proof of introduction, what it happened? This leads to contradiction. Our assumption is wrong. Therefore 3 plus 2 root 5 is irrational number. 3 plus 2 root 5 is irrational. So a simple concept I'll explain. Rational plus rational gives rational. Rational minus rational gives rational. Rational into rational gives rational number. Okay. Rational divided by rational you will give rational. We will get rational number only. How about irrational? Irrational plus irrational you will be getting irrational. Irrational minus irrational you will be getting irrational. Irrational into irrational you will be getting irrational. Irrational divided by irrational is equals to irrational. This is a concept. Now, if we take irrational plus rational, irrational minus irrational, irrational into rational, irrational divided by rational. In all of these concepts, we cannot say the perfect answer. We cannot say. It can be either rational also, it can be irrational also. In these conditions. If irrational plus rational, irrational minus rational, irrational into rational, irrational by rational, we cannot say. Okay. So this concept is simple. Just keep in mind. Okay. Rational minus rational is rational. Irrational is not equal to rational. Therefore, this leads to contradiction. Our assumption is wrong. 3 plus 2 root 5 is irrational. Clear? Okay. Prove these numbers, the given numbers are irrational. Okay. What we will be writing the same story. Let us assume to the contrary that 1 by root 2 is rational number. 1 by root 2 is rational number. So what I'll be considering, 1 by root 2 is equals to, is in the form of a by b. Okay. I will connect p by q, anything is okay. Where a and b are co-prime and b is not equals to 0. B is not equals to 0. What I'll do? Cross multiply. B is equals to root 2 into a. Root 2 into a. B upon a is equals to root 2. B upon a is equals to root 2. Now here where b and a are integers. B and a are integers. This is a rational number. Therefore, rational is not equal to irrational. This is irrational number. Correct? Rational is not equal to irrational. This leads to contradiction. Our assumption is wrong. Therefore, 1 by root 2 is irrational number. 1 by root 2 is irrational. Hope this is clear. We'll go to the same Same story you need to write. Let us assume that to the contrary that 1 by root 2 is, instead of 1 by root 2 I'll write 7 root 5 is rational number. Okay, 7 root 7 7 root 5 is equals to, is in the form of p by q. We are assuming rational number. You got to read the same story where a and b are co-prime and b is not equals to 0, and b is not equals to 0. How to solve this? Root 5 is equals to a upon multiplication goes to division 7b. Okay, therefore this is irrational and this is rational, correct? Therefore irrational, erase this, irrational is not equals to rational. Okay, you can write the same points where a and b are integers. This leads to contradiction. Our assumption is wrong. Therefore 7 root 5 is irrational. You can add the same points here. Okay, hope this is clear. We'll go to the last and final question of this exercise. 6 plus root 2 is equals to a by b. Okay, by contradiction, let us assume to the contrary that 6 plus root 2 is rational number. At the same point, I will put the direction here. Okay, 6 plus root 2 is equals to a by b. Root 2 is equals to a by b minus 6. This side I'm saying. Root 2 is equals to a minus cross multiply 6b upon b. Okay, root 2 is equals to a by b minus 6b by b. Now watch carefully. This is rational and this is rational. What I told, rational minus rational is rational, and this is irrational number, correct? Irrational number. Seeing this all, irrational is not equal to rational. Irrational is not equal to rational. Therefore 6 plus 2 root 2 is a irrational number. We can conclude it. This leads to contradiction. Or you can tell this contradicts our assumption. This contradicts our assumption. This contradicts our assumption that 6 plus root 2 is irrational number. 6 plus root 2 is rational number. 6 plus root 2 is rational number. Therefore 6 plus root 2 is irrational. This completes your chapter. If you have any doubt in this chapter, put me in the comment section. Please like, share and subscribe to the channel. Thank you. Bye bye.